The second case is about using this open source software and services for my specific course, which is called collage course. So I used GeoGebra, Inkscape, and Tinkercad service to produce the final project result for my students. So I'd like to show my mind map, which include the information about the course. So my course usually consists of OK mind map page. This page includes many information and about the sites and the objectives of the learning, and many videos and tasks to be performed on weekly basis. I've been learning these courses for a long time, and when I ask students to make a project using 3D printer and Arduino, the results are almost same. Something like a movable trash can, garbage can, so which is available on Google search as Arduino project. So I changed the strategies. So I ask them to reference the site on the internet, which is something like this. Okay, something like this site. And these sites provide many different kind of mechanical movements mechanisms. So I asked my students to implement the combination of these mechanical movements to produce their result. And mostly the gear is basic parts, and in addition to that, they can find the movements of their own interest. And the good part of this one is they provide the animation, and also if they can capture this this movement, they can extract the edges using Inkscape. And with Inkscape, they can import that as a SVG file into the Tinkercad service. So that's the way they can actually produce the 3D part. And with that one, they are supposed to design Arduino part, which make the mechanical part to move. So the first process is using GeoGebra to create the mechanical movement. Okay, let's see that one of the things like this. Okay. Using GeoGebra, we can do something like this. This is more abstract, but they can simulate the movement of gears and the positions of the gears and the constraints which they can predict using these GeoGebra things. And let's do some others. Okay, using the seizure like mechanical movement, we were able to implement the GeoGebra simulation like this. Okay, also here like this, and you can see that which boundary they can physically available movement is achievable. They can check it on internet. Okay, after that they can, as I explained before, they can use Inkscape to produce that SVG file produced by edge detection functions of Inkscape. Then SVG file is imported to Tinkercad. Tinkercad is open source. You can use it for free, and it provides Arduino simulator and also 3D modeler functions on browser based. So in Tinkercad they can produce actual part, and the G code is generated, and the final product is produced using 3D printers. And that 3D printed object can be controlled, its movement by Arduino controller, something like this. A joystick, the students can produce the control, and you can see that the 3D mechanical parts are controlled using the Arduino controllers. So those are the way that they can produce the final ones. Okay, and students was able to produce many different outputs, something like this. Of course, now they are in the stage of prototype, and some wings. Okay, this is a simulator. Frog movement. Okay, video, let's see. Okay, so this is just one simple things. They can control that the movement of a bug using Arduino control. But this one looks like that meaningless at first, but if they come up with the better ideas, probably there is more sophisticated movement, or maybe some useful and meaningful movement, something like a robots and the small micro things they can move according to their intention. So those are the things that are the second stage, the second cases of my OSS for education. The final one is producing OBS and OpenShot videos and Lens Studio for videos. The video produced produced videos can be uploaded to my YouTube. So that's the way everything is connected in a circular connection, connected implementation into the hub of educational environment. And this one I think also already have information about this part as a blog or YouTube already, so I'm not going to explain in detail about this project. And here you can find more about the third cases of my presentation. Okay, so for the conclusion, okay, one more. So there are more things I can introduce, something like you can use OpenOffice and LibreOffice. That's the pre-version of Microsoft systems, Microsoft Word and Excel and PowerPoint. The format is comparable with this one. So in the developing countries, they can use this Office suite without paying much money. And for the MATLAB is a commercial version, but there is an open source version called Octave. And if you are working for a small company and have a license problem with MATLAB, they can use Octave. The source is compatible with MATLAB source. So MATLAB file can be readable using Octave and runnable also. I think that MOOC and OCW is a kind of extension of open source software. So MOOC is a service actually. The open source software, the paradigm of open source software of openness and sharing and peering is extended to the e-learning service that what we call MOOC, Massive Online Open Courseware. And previous to that, there was OCW, which is Open Courseware. It's open of the courseware, things like a PDF and quiz materials and images and learning assets shared and opened on the internet. Okay. So I think this is also part of open source software paradigm. And if you install Linux, there are many available softwares for educational softwares. You know what called Ubuntu is educational version of Linux. And in the developing countries, the operating system is very useful. Not the necessity of purchasing a commercial softwares. And Audacity is audio management systems softwares. You can modify the audios modify and enhance the audios or sounds using Audacity software, which is pretty open source. And there are many open source directories. You can click this one, and if you go to the directories, I already opened it on here, like open source educational directory. So many different kind of open source softwares and services, especially related to the open source or educational purpose, are listed on here. So please take a look at it and hope you can have a benefit of using open source software on your own work. Okay, that's my presentation, and the conclusion is actually made by ChatGPT. I provided this PowerPoint presentation to ChatGPT and asked to draw conclusions from the contents, and this is very meaningful and great things that ChatGPT did. The first is integrated use of open source software and open services, and promoting learner autonomy and creativity. Those are the things we can get using the open source software. Provision of open educational contents and improving practical and creative expression skills. Ease of creating and sharing lecture contents. When individually powerful tools are combined, they produce a synergistic effect on enhancing learner autonomy and creativity, and suggests further future development directions for engineering education. Thank you for listening my presentation.